All right. Ow. Huh? All right, factoring day 1. So I love factoring. I think it's like a puzzle. And so this is like one of my favorite weeks of teaching. Notes, factoring, greatest common factor and simple trinomials, okay? So basically, we're factoring a polynomial means expressing it as a product of other polynomials, mainly as either a monomial times a binomial. And we're going to talk about that in a minute. Okay. So method number 1 of factoring polynomials with a common monomial factor. Okay. What a monomial factor means is that you have nothing being added or subtracted. So it could just be 2. It could just be 2x. It could just be 2x squared. It could just be x squared. These are examples of monomials, okay? Mono means 1. Okay? What tends to happen when you factor a monomial is that you're going to be left with a binomial or a trinomial. What does bi mean? 2. So that means you're adding or subtracting 2 things. Notice how I'm saying adding or subtracting and not multiplying. So the first thing we do is find the GCF. So you ask yourself, looking at the numbers and the variables when possible, what is the greatest number that can equally divide into both of them? So if I have 15 and 9, their greatest number that divides evenly into them is 3. So the greatest common factor is 3. And I'm going to divide each one by 3. So when I divide each one by 3, I end up with okay. When you write your solution is always the GCF times your quotient. Quotient is what comes after you divide, right? This is my quotient, okay? This is my GCF. Your rewrite is GCF times your quotient. So my final answer is 3, parenthesis, 5m squared minus 3. Fully factored. Wait, close. How do we feel? It's super simple. This is basically it for method number 1. All right. So now we have 5x squared plus 10x. Again, we're going to find the GCF. So you're going to compare the numbers and compare the variables. So when I compare the numbers, so between 5 and 10, what is the greatest number that divides evenly into both of them? 5. Now, when you look at the variables, what is the least amount of x's do you have? What is the 1x, right? So when you're comparing variables, you're looking for the least amount. And the least amount they have in common is 1x. Okay? Then you divide by the GCF. So I'm dividing by 5x, dividing by 5x. My quotient, 5 divided by 5 is 1. X squared divided by x. Does anyone remember what you're doing when you're dividing exponents? Perfect. Dividing exponents means you are subtracting. So what is 2 minus 1? 1x. 10 divided by 5 is 2. And 1 minus 1 is 0. So again, it's GCF times your quotient. So we have 5x times x plus 2. Questions? Feeling it? All right, let's get a little bigger. So now, instead of having a binomial, what do we have? A trinomial. Why is it a trinomial? There's three factors being, three addendums, right? Three things being added and or subtracted together. So again, we're going to start with the numbers. They all can be factored by 2. And then we're going to go to the letters. So we have x cubed, x to the 5th, and x. What is my least amount of x's? Just x. So I divide by 2x. And when I divide by 2x, what do I get as my quotient? 4. Remember, you're subtracting. What's 5 minus 1? So you have 2x to the 4. What's 3 minus 1? And then 1 minus 1 is 0. And your solution is always your GCF times your quotient. Our GCF was 2x. Our quotient was 2x to the 4 minus 3x squared plus 7. Easy enough? All right. Let's take it up a step. This is only a binomial. It has a lot of variables, but it's only a binomial because there's only 2 things, 2 expressions being added together, right? So I'm going to look at my number first. And when your leading coefficient is negative, your GCF is going to be negative. So this is my leading is negative. Do we see that? So I'm going to divide by a -4. Okay. Then now I'm going to compare my variables. What is the least amount of A's do I have? 1A. What is the least amount of B's do I have? And what is the least amount of C's I have? Okay, so we divide. So we're dividing this by -4 ABC squared, -4 ABC squared. A negative divided by negative is a positive. A squared divided by A is A. B divided by B cancels. C squared divided by C squared minus, well, let's see, a negative divided by a negative is a. So instead of minus, it becomes a. A divided by A is a to the 0, which is 1. You're good. B squared divided by B. So we have 3B. And then what happens to the C squared? So that's my quotient. So it's your GCF times your quotient. So we have -4ABC squared 2A plus 3B. Super easy, right? Good? All right. Next, we have another trinomial. Why is it a trinomial? It has 3 expressions being added or subtracted together, right? So we're going to start with the numbers. So looking at the numbers, what is their greatest common factor? 3. Now we're going to look at the variables. When you're looking at the variables, you're comparing what is your least amount. So x to the 4th, x to the 3rd, x squared, x squared. And then now we're going to look at y. Well, this one has no y. So my least amount of y's is y to the 0, right? And remember, anything to the 0 power equals 1. But is there any reason to write GCF of 1? No. So I can't use the y's because this term does not have a y. No y. So my GCF is just 3x squared. Remember, with exponents, with variables, it's your least amount. And what is my least amount of x's? So I'm going to divide each number by, each added in by 3x squared, 3x squared, 3x squared. What do I get as my quotient? 3 divided by 3 is 1. X to the 4th divided by x squared means 4 minus 2 is 2. Negative 9 divided by 3 is x cubed divided by x squared is x cubed divided by x squared. And y is just y. 6 divided by 3 is x squared divided by x squared. 1. Is there any reason to write the 1? No. So I have my GCF, I have my quotient. So my answer is 3x squared, x squared minus 3xy plus 2y squared. Okay, the important thing about all of these is that if you're unsure about your answers through every single one of these problems, you can go back and distribute, right? And double check yourself. So I'm gonna model it with this one. If I'm like, ooh, I don't know if I did this right, I'm gonna distribute 3x squared to all of them. And if I don't get my original, then I did something wrong. So 3x squared times x squared is 3x to the 4. 3x squared times negative 3xy is negative 9x to the 3rd y. 3x squared times 2y squared is 6x squared y squared. So I can always check myself if I'm unsure about my answer. All right, any questions about GCF? Easy peasy? All right, flip it on. Yep, on you. So yes, I would like for you